Good day, friends, and welcome to Physics and Mathematics lovers. Today's tutorial, we are going to discuss what is called parallelogram law of vectors. Remember, we have solved some examples on this topic. Today, I want to bring to you another method of what? Adding vectors together. But before I do this, please do not forget to share this video as you are watching, and also subscribe to our YouTube channel where you see varieties of videos, lectures that you are going to benefit from. Thank you as you do so. Now, when we look at parallelogram law of vectors, yes, remember addition of vectors involves both trigonometrical method and graphical method. Now, in our trigonometrical method, that is where we have what? When two vectors are acting at an angle that is greater or above 90 degrees. When two vectors are acting at an angle which is more than this or even below, so we use parallelogram law. So we cannot use this perpendicular angle. So what the law simply says that, if two vectors are represented in magnitude and direction by the adjacent sides of what? The parallelogram. Say that what? The resultant, which is drawn from their point of intersection, look at it here, for that point of intersection, will represent the magnitude and direction of that vector. Look at it here. This is what? Parallelogram. Now, this is what? The diagonal that is drawn. This angle here, this large angle here, is the theta. But now let us draw the diagonal that we are talking about according to the law. Say that this diagonal here that is drawn from their point of intersection, it will represent the resultant of these two what? Vectors acting at an angle which is what? Theta. So now, the angle with which this resultant is now acting, that is the direction. The angle is now this alpha. It's no longer this theta. So according to the law, say that what? These two sides of a parallelogram is represented here. The two vectors represent it what? In magnitude and in direction. So that what? The diagonal that is drawn from their point of intersection, and it will represent the resultant of what? These two what? Vectors in what? Magnitude and direction. Now, let's look at how do we get this arrow. Now, what we are interested in, when we complete the parallelogram, let us complete the parallelogram. Let's complete it. You discover that we are forming what? A parallelogram or shape. But now this angle here, this one, is not what we are interested in. We are interested in the angle that we can be used to calculate when we bring out this. Let us bring out this triangle. If I bring out this triangle, and at the end of the day, I am going to have to need this angle here, this very angle. I will be in need of it. So this angle will be the obtuse, like this. So at the end of the day, this is what I am going to obtain. This is the angle now. So this is your what? Resultant. And now this Vy will also be equal to what? Here. And this Vs will be here. Which means Vs will be here. Now this Vy, it will now represent here. That is what? Vector 1, vector 2. Now at the end of the day, this angle that we are going to use, we are not going to use this now. At the end of the day, this angle here and this angle, the whole of this angle and the whole of this angle, they are correspondent. They are facing one direction. So which means for me to get here and here, they are on a straight line. Which means here I will be what? 180 minus what? Theta. So here, this angle here will be what? 180 minus what? Theta. And here is the direction in which this resultant is what? Acting. That is your alpha. Now, how do I get this now? You know that, let's assume this is what? Angle A. Let's say here B, C. You remember your cosine rule in mathematics. Your cosine rule says that what? I will represent here by what? B. I will also represent here by what? C. I represent here by what? A. So at the end of the day, I am going to get my resultant, which is what? AB, which is equal to C now. So we can call it what? R. Since it's already denoted as R, I will say R is equal to what? A, the side of this one, which is what? A square plus what? B square, then minus 2AB cos this angle here, which is this angle, 180 minus what? Theta. So this is the formula we are going to use. This is what the resultant, r square equal to what, this one. So at the end of the day, you are going to find the root. R now will be equal to what? Root, square root of what? A square plus B square minus 2AB cos 180 minus what? Theta. So let me tell you another thing that you need to understand. Why do I put this minus here? So if I don't want to use it this way, I can what? Just put the angle. I will just use the angle at once by saying, let's say for example, the two vectors are acting at what? Angle 60 between what? Each other, angle 60 degree. Instead of me to come and put 180 minus what? 60, I will just put 60 degree here. What will happen at the end of the day, when I do some mathematical computation, I am going to change this. This will turn to a plus for the other one. So what will happen now? Let's see what will happen. Assuming I am to use it directly, let's assume two vectors are acting at what? Angle 60 degree. So we just draw your what? Complete your parallelogram. So when you complete it, at the end of the day, you have your vector. This is what? Angle 60 degree. Now what will happen? You just put it, your 60 degree, it now become your resultant r square equal to what? A square plus B square plus 2AB then cos theta. This or theta now is your 60 degree. So this one, don't use it direct. If you use this, or you use the former one I gave you, r is equal to what? Square root of what? Yeah, or A square plus what? B square plus 2AB cos theta directly. Are you getting it now? But the other one, if I want to use this other method, then I have to put what? 180 minus what? Theta. That is cos 180 minus theta. Because in our trigonometry, your cos is negative. Cos theta is negative. 180 is what? More than what? 90 degree. That is what? Obtuse angle. So because of time, I will not have enough time to evaluate now with example. In our next video, I am going to use this one to solve more questions. Please do not forget to share this video. God bless you.